Hi everyone, welcome to new video. Today we are going to discuss maximum intervals overlap. This is one of the nice question where you will in this video you will definitely learn something new. Yeah, even if you know how to solve this question. Now coming on to the companies which asked this question recently are that is Flipkart, Accolade, Amazon, Visa, DirectEye, and many of the companies asked. Okay, now let me see what this question states here. Consider a big party where n guests come into it, and a log register for a guest entry and exit time was maintained. Find the minimum time at which there were maximum guests at the party. Note that the entries in the registers are not in any order. Guests are leaving after the exit time. Okay. In this, what this question states is, let me explain. This is the given test case, right? The output is 3 and 5. Let me explain what this question states. Assume yourself you had given you are a person where you are the guest or a like a function manager. There were some guests coming and you have to maintain the entry and exit time in a logbook. And you have to and the manager of you said that you have to maintain the minimum time at which maximum guests entered. So given question is for example the first guest you can see the first guest entered at 1 minute and exit at 4, right? So we'll for guest one that is 1 till 4. Now for guest 2 will arrive at 2 and exit at 5. Guest 2 arrive at 2 exit at 5. Now for guest 3 he arrives at 10. Let's suppose this is 10 and exit at 12. Now for guest 4 that is 5 and 9. Here it is 5 and here it is 9. And guest 5 there is 5 and 12. There is 5 and 12. If you see in this graph you can clearly see that in the 5th minute that is here and here there is you can see 2 to 5 here 2 to 5 5 to 9 and 5 to 12. This is the time where maximum amount of guests arrive. So for example you can see it is at the output that is 3 is the maximum number of guests and arriving at 5 time that is 5. So coming on to this approach, I think brute force approach would be you have to take the entry and exit time of the first member, and within that limit you have to check all the entry time of all the guests. That is 1 to 4. Are there any guests other than me who are arriving in the time limit of 1 to 4? You will check one like this, and here only one, and we'll have a that is maximum pointer. Whenever it gives the maximum answer, we will map that index and also the answer. So this is what the brute force approach is. Now coming on to the optimal approach. For example, they had given there is 1, 2, 4, 5 like this. So my approach would be like I will take the minimum point that is minimum of all this entry and exit time, minimum of all the entry time that is 12 and maximum of all the exit time that is 12. 1 and 12. I will take these pointers and yeah, let me go. So this will be like I will maintain an array that is 0 to 12, and so that is the max minus min. Max would be max max was 12 and min was 1. So I will map the max on min and I will store 0 to max. Okay, now what the approach is. So you had given that is 1 to 4 and 2 to 5. So here they had given 1 to 4. Wait a minute, I will copy that. They had given, wait a minute, I will erase all this. Wait, there is a okay. In this question, you can see the first guest entered at 1 to 4. So I will simply do nothing. I will increment 1 to 4 index. There is 1 and here 2 also 1 and now 2 also 1, for 3 also 1 and 4 also 1. And next guest arrives at tooth tooth unit and also exits at 5th unit. So I will increment from 2 to 5 index, that is 2, 2, 2, and here 0 is there, so 1. Now coming on to the third guest arrives at 10 and exits at 12. 1, 1, and 1. Now the fourth guest arrives at 5 and exits at 9, so 2. Here all ones, 1, 1, 1, 1. It's ninth, right? Yeah. Okay. Fifth guest arrives at 5 and exits at 12. So there is 3, right? Yeah, 3, 1, 1, 1. And there is 2, right? Yeah. 2, 2, 2, 2, 2, 2. If you compare all these indexes, we can see that 3 is the maximum amount of 3 is the maximum, and it is situated at 5th index. So by seeing this, we can come to a conclusion that at the 5th time there will be maximum guess. So this is what the approach is. We can see here we are calculating again and again. We are for a time limit for 1 to 4. For example, here for 1 to 4 we are iterating till 1 to 4, that is 1, 2, 3, and 4. And for 2, that is 2, 3, 4, and we are iterating within that limit. So it will be given a, so that is, yeah, time complexity would be more. Coming on to the time complexity of this approach, we can see n is the number of units. Yeah, n is the number of units, right? This is n, that is n is equal to 5, and this is the limit which we have to traverse. So for n units we have to traverse m max minus min plus 1. So that is time complexity would be n into max minus min plus 1. This would be the time complexity. In worst case it would lead to n square. In worst case means, for example, you had given 1 to 12, 1 to 12, 1 to 12. So rather than 4, they had given 1 to 12, 1 to 12. In that case, it would definitely give n square. Space complexity, you all know that is max minus min plus 1. This would be the space complexity. Now coming on to the better approach than this is, like, that is, yeah, coming on to the better approach. This is something like I don't remember the algorithm clearly, but let me discuss. The same thing I will copy right here. Now, in this example, rather than traversing all those things, I will maintain, like, I will increment the starting time and decrement the exit plus 1th time. So I will maintain the 13th index. For example, it doesn't matter, like, even increasing one index. So I'm doing, I will increment a 13th, I will increment one plus one index, maximum plus one index. Now you can see here the entry time is 1, so I will increment 1. Rather than incrementing all this 1 to 4, I will decrement exit plus 1, that is 4 plus 1 is 5, right? I will exit, I will decrement that index minus 1, that is minus 1 here. Similarly for 2, we'll increment by 1, 2 to 5 it is, so I will decrement 6 to minus 1. Third, 10 to 12, that is 10 will be plus 1, and 12 it is there, so 12 plus 1, that is 13. So this is why I incremented one index. 13 would be minus 1. And now coming on to the fourth case, there is 5 to 9. So 5 here minus 1 will increment 5, that is 0, to 9, that is 9 plus 1, 10. Will decrement 10 by 1, that is 0. Now the third case would be 5 to 12. So I will increment 5 by 1 and I will decrement 12, right? 13 by minus 1. So minus 1 would be minus 2. Now, so the final answer would be 1, 1, and 1, and 0. Here minus 1 is there, minus 1, and here minus 2. Now we will take prefix sum of all these given answer. So prefix sum would be here, the remaining index will be zeros. So prefix sum We'll maintain a prefix sum. Here that would be 1, here that would be 2, here that is 1 plus 2 plus 1, that is 3 at the 5th index. Yeah. Let me write here, that is 0, here would be 1, here would be 2, here would be 3, that is 1 plus 1 plus here. After maintaining all this, we have to maintain the prefix sum array. So that is 3, and similarly here it will decrement 2, and here minus 2, that is 0. Comparing all the prefix sum, rest would be 0. We can see 3 is situated at 5th place. The answer is 3 and 5. So this is like optimal approach. And there is another better approach than this. Rather than traversing all these things, I can do it easily by maintaining two pointer technique. Let me discuss how it is. And yeah, coming on to the time complexity of this approach. What would be the time complexity? So that is O of n. You are not traversing like all the time. We are simply incrementing and decrementing by taking the indexes. So that is O of max minus min plus 1. Similarly, space complexity would be also same. We're traversing only once, so that doesn't matter. Yeah, that is time complexity and space complexity. Coming on to the more optimized and better approach than this, that is two pointer plus greedy approach. So these two approach discussed here is greedy approaches. Now coming on to the third approach, that is best and efficient approach for this question is given they had given entry and exit time for you. So what I will do is I will just sort the entry and exit time. I will sort both this entry and exit time. So after sorting, yeah, I will sort. After sorting, this would be the obtained index, right? For this, I will sort this, and what I will obtain, that is, say for example, if I sort entry time, that is 1 2 5 5 10. 1 2 5 5 10. Similarly for exit time, 4 5 9 12 12. 4 5 9 12 12. Okay, I got entry and exit time in a sorted manner. Now what I will do is I will simply maintain two pointers. Two pointers, one here and one here. Now let me maintain a count and a index to map the count and index. Okay. Now what I will do is I will check whether the entry time is greater than or lesser than entry time, exit time. So one, we can see clearly that 1 is obviously lesser than exit time. So I will increment the count. Here the count would be 1. Count initially was 1. Why I say means, for example, you are the first guest and we have to consider you, because without considering you there will be no guest present. So I will consider count as 1 initially. Now I will consider count as 1, and then I will move to the next index. Here, move to the next index, there is 2, and I will check whether 2 is greater than 4. No, it is lesser than 4, right? 2 is less than 4. Now I will increment, here it is incremented, right? Initially count was 1 and we have incremented count. Now here it will be 2, and now we can see 5 is less than 4, right? 5 is less than 4, so we'll decrement the count. Now we'll decrement the count, and now we'll increment, and we'll increment the exit pointer by 1, and we'll check whether 5 is lesser than 5. 5 is lesser than or equal to 5. Yeah, it is obviously lesser than equal to 5. Why I'm saying this is because in the question there clearly mentioned that guests are leaving after the exit time. So we will increment after the exit time. So we have to consider lesser than or equal to. Now that is 5 lesser than or equal to 5. Yes, obviously. We'll increment by 2. And now we'll check whether 5 is lesser than or equal to 5. Yeah, I will increment by 3. I think you all got the approach. And now for 10, 10 is less than 5, decrement. And now for 10, 9 lesser than decrement. and now 10 12 increment by 1, 10 12 increment by 10 12 increment by 1. So here we can see 3 is the maximum amount of index we are obtaining here. So whenever when we are traversing this, we will check whether this is the maximum amount of count I got, or like we will maintain a pointer for maintaining the maximum amount of guests incoming. Sorry. Now let's code it up. Wait a minute. Now let's code this question. Code the answer. Now I will code this for code. I will write the code for this approach. I think I explained in a better way so that you can code this and this approach by yourself. Now let's coming to this approach. Okay, what we have to do first. Okay, I will write C++ code. I recently switched from Java to C++, so I will write C++ code here. Now, initially, what we have to do, I think we sorted here, right? We sorted here after sorting. So we sorted. We have to sort. We have to sort entry, right? Entry time, entry from 0 to nth index, right? 0 to n. We sorted n. Similarly, we have to sort exit time, sort again exit, right? Exit, exit plus n. There is capital N. After sorting entry and exit time, we will maintain two pointers. So here, after sorting entry and exit time, we will maintain pointers and all those things to traverse in an efficient manner. That is, we will maintain there is start index for 1, start index would be 1, and end index would be 0. Why I am saying this? See, in this, initially we consider this person, he is in the party, so we will consider from this index and exit from this index, as we are incrementing the count by 1. So that is what I said here. End would be at 0. Then what we have to, like, yeah, we also want to maintain the count and the index, right? So we will maintain count. We'll maintain a count variable to maintain the amount of tests presented in that index, right? Entry 0. Answer would be entry of 0. No, wait a minute. Yeah, count would be initially 1, right? And to maintain the answer, to maintain the index which the answer is present, I will maintain that as entry of 0. Initially, I will assume that this itself is an answer. In this answer itself, the maximum amount of guests will occur. So I am meant assigning 1 as my answer variable. Now I think count, answer, everything is declared. Yeah, it is declared. Now what? Now while I have to traverse through that, like, given arrays. So while we maintain start should be less than n, and n should also be less than n. Yeah. Yeah. Now what? Now what? Now we'll check if entry entry of s is entry of starting is less than or equal to exit exit of ending. Now what we have to do? What I am writing here is basically we'll check whether entry of this index is less than or equal to exit of this index, or the pointer which is it is pointing to. So that is what I'm checking here. If it satisfies the condition, what we have to do? Increment the counter and increment the entry index. I will do increment the counter, that is there is starting index, right? Starting plus plus and count will also be incremented. Count plus plus. Now, else, if this is not the case, what we have to do? Okay, in this in this example, 5 and 4, it is not the case. 5 is not lesser than or equal to 4. So what we have to do? Decrement the counter and increment the exit pointer. So that is what I will do here. We'll increment exit pointer and we'll decrement count. Count would be minus minus. Now, after doing this, and we'll check. We have to maintain the maximum pointer. So after doing all this, if like I will increment. Okay. Yeah, I want to maintain the maximum pointer track also, right? The count will increment, decrement, like it will happen like that. So I will maintain another pointer that is max count, that would be initialized to 0, not initialized to 1 or 0, it doesn't matter. Now I will check whether max count, if it is less than count, simply assign max count to count. And what we have to do? Answer. Okay. And yeah, answer would be entry of 0, right? Now what we have to do? Answer would be entry of s minus 1. Why I'm doing this s minus 1? Because I am using one based indexing right here. So I am maintaining answer is equal to entry of s minus 1. Now what? This is basically the approach. Everything is complete, I think. So now I want to return where it is. Yeah, I want to return given vector, right? So I will return what I have to return. I had given the count and the index, right? So I will maintain the count, that is max count, right? Max count, and other than max count, what I have to return? I have to return answer. I think this is sufficient and it should run. Let me check. Okay, it's giving error. Yeah, it's a typo. Okay, yeah, it's giving 3 and 5. Let's submit it. Hopefully, it should not give any errors. Yeah, it passed the test case. So this is the approach. If you yeah, if you didn't get this approach, see once again the video. It's a nice question where you can glance all the concepts like greedy approach, two pointers, all those things. So watch clearly, and if you have any doubts, you can ping me in the comment, or I will drop the LinkedIn and all those links. You can follow me there. Thank you guys. Thank you.